look at curve sketching. So curve sketching, remember, we're basically looking at stationary points and the shape of a graph. So to find a stationary point, make the derivative equal to 0, and all the different types of stationary points can be seen down here. So determine the stationary points of f of x and justify the nature. So they find the derivative. Oops, almost wrote the x. So that's 4 minus 4x minus 3x squared. And at stationary points, it's equal to 0. To solve for it equal to 0, I'm just going to take a negative whole thing. 6 minus 2 gives us 0, so if we do 3x plus 2, x minus 2, we then have, oops, wrong way. We then have 6 minus 2, which gives us 4x. So then x is 2 over 3, or x is equal to 2. Then, I'm going to draw a sign diagram of the curve. So we have a negative parabola. There's negative 2, 2 over 3. So that's negative, 0, positive, which gives us a min. And then for 2/3, we have positive, 0, negative. So then at x equals to 2/3, we have a max. I just realized I've got to solve for x. So then we have 2 minus 8 minus 8 plus 8. And at 2/3, I'm going to change my net calculator. So we get 94 over 27. Okay, B, the curve y equals to ax squared plus bx minus 24 has a stationary point at -1, -25. Find the values of a and b. So for this, you'll get a set of simultaneous equations. Let's up the first one in. Oops, it's a minus. So then a minus b is equal to -1. Then the other one is it's a stationary point, so find the derivative. And it's equal to 0 at the stationary point. So -2a plus b equals 0. Then if I add the 2, I get -a equals to -1. A is 1. Then a minus b gives us -1, so b is 2. So curve sketching, I'm sure you remember how to do it from last year. Just pause the video if you want to read through it. Feel free to read through it. Alright, let's just go through an example. Let's find the x-intercept for the first one. that y equals 1/2 x cubed minus x squared plus x minus 8. That's what numbers go in. They're the only number that is in full. So then the factor is minus 4. Do your long division. Make sure you subtract each time. So then y is equal to x minus 4 1/2 x squared minus x plus 2. And then we can stop there. So the only x-intercept we have is x equal to 4. And our y-intercept will be at 0, -8 reading off the graph. Then we need to find any turning points. I suggest you multiply the whole thing by 2 here. Then we can factorize the whole thing by 3 as well, and divide it by 3 on both sides. That's perfect square, so then we have x minus 2 squared equals 0, so x is equal to -2. Put this into our function, then we'll get y equals to -8/2 minus 12 minus 6 minus 8. So that's -4 minus 12 minus 6 minus 8 minus 30. So then we have, what is it, x equals to 4 as an intercept. Then x equals -2 as our turning point, which is somewhere down here. So then, because it's a cubic, you'll have to do, that doesn't seem right, hang on. Right, I missed a step, that's why. Because this is a perfect square, we have positive, 0, positive. So it must be a point of inflection. So positive, 0, and then positive. That doesn't look nice. I'm just going to rub that out. There we go. So it's 4, it's -2, -30. And then our y-intercept is -8. State the domain in which the function is strictly increasing. Well, the function is pretty much increasing the whole time except at the point of inflection. So then for part B, x is an element of all the real numbers except that particular point, which is at -2. Alright, function has a restricted domain there. For A, specify the coordinate for endpoints of a domain. So 7/4. and then also 4. Alright, B. Obtain the coordinates of any stationary points and determine its nature. So, find the derivative. Half minus over x squared. Make it equal to 0. So then times x squared on both sides. So x squared is equal to 4. X is then equal to plus or minus 2. Now, because minus 2 is out of our domain, we only have to worry about x equals 2. Okay. Because we have a negative truncus, that would be the shape of the that would be the shape of the right hand side of a truncus, the positive side. So then we would have positive, 0, positive. So when you sketch a graph, just keep that in mind. So we have, if you remember how to do addition of coordinates, x plus x over 2. Maybe I'll just use a different color. That'll probably make more sense. And then we also have 2 over x, which is in a hyperbola. We're ignoring this side completely, so I can leave that. Then we're starting at a quarter, which will be somewhere here. And then we're going up to 4, which is somewhere here, here. And then we'll have the turning point right at 2, which is around there. So the blue one will be the shape of it. But we need to restrict the domain, which I didn't do. So it should only go from there to there. Alright, state the absolute maximum and absolute minimum values for the function. So that means we want the biggest, so the largest point and the smallest point. So the smallest point for this will be at 2, 2, and then the maximum point will be at, that doesn't look quite right. 65 over 8. But that's 8. Whoops, I drew that a little bit funny. That should be down here. And that should be up there. There we go, that makes more sense. So the absolute maximum will be at quarter 65